Introduction. In our day-to-day life, we come across various shapes. These shapes are plane shapes, two-dimensional, or some of them are solid shapes, three-dimensional. In this chapter, we will study how to find some measurements related to circle and the surface area and volume of solid figures. Circle, arc, sector, segment. A secant divides the circle in two parts. Each part together with the point common to the circle and the secant is an arc. Center side arc is called a major arc. Non-center side of arc is called a minor arc. In the adjoining figure, triangle AOB is the central angle and arc AXB is a minor arc. Arc AYB is a major arc. OAXB is a minor sector and OAYB is a major sector. The segment AXB is called the minor segment. It is shaded region and the segment AYB is called the major segment. The center of the segments lies in the major segment. Complete the following statements. The measure of semicircle is 180 degree. Measure of a circle is 360 degree. M arc AXB is equal to angle AOB is equal to theta degree. M arc AYB is equal to 360 minus M arc AXB. Length of an arc. Length of an arc of a circle. Arc length is the distance along the curved line making up the arc. Length of an arc is longer than the straight distance between the endpoints. That is, length of the arc is longer than the corresponding chord. The length of an arc depends upon the central angle as well as the radius of the circle. An arc is the part of the circle. Length of arc 1 is equal to theta by 360 multiplied by circumference C. Length of arc L is equal to theta by 360 multiplied by 2 pi r. Activity 1. Complete the following table. Measure of the arc, length of arc, ratio, L by theta. 360, 2 pi r by 360 is equal to pi r by 180. 180 degree, pi r by 180. 90 degree, pi r by 2. Pi r by 2 multiplied by 1 by 90 is equal to pi r by 180. 45 degree, pi r by 4. Pi r by 4 multiplied by 1 by 45 is equal to pi r 45. Pi r 180. Length of the arc decreases with decrease in the measure of central angle, keeping the ratio of the length of the arc L to the central angle theta constant. The length of the corresponding major arc will be the difference between the circumference and length of the minor arc. Area of a sector. Sector of a circle is the part of the circle enclosed by two radii of the circle and their intercepted arc, that is, arc between the two ends of radii. Area of sector of a circle is the area of the part of the circular region bounded by two radii and the arc. The area of the sector is depending on the central angle as well as the radius of the circle. A sector is the part of the circular region, so the ratio of the area of the sector A of the total area of the circle is same as the ratio of the measure of central angle of the sector to the measure of the circle. Area of the sector by area of circle is equal to theta by 360. Activity 2. For the circles with equal radii as shown below, find the shaded areas and compare. Measure of arc. Area of the sector. Ratio A by theta. 360. Pi r square by 360. 180 degree. 1 by 2 pi r square. 1 by 2 pi r square by 180 degree is equal to pi r square by 360. 90 degree. 1 by 4 pi r square. 1 by 4 pi r square by 90 is equal to pi r square by 360. 45 degree. 1 by 8 pi r square. 1 by 8 pi r square by 45 is equal to pi r square by 360. Note, area of the corresponding major sector will be the difference in the area of the circle and the area of the minor sector. Relation between the area of the sector and the length of an arc. Area of the sector is equal to r by 2 multiplied by length of the arc. A is equal to L multiplied by r by 2 is equal to theta by 360 multiplied by 2 pi r, and A is equal to theta by 360 multiplied by 2 pi r square. Theta by 360 is equal to L by 2 pi r, and theta by 360 is equal to A by pi r square. Theta by 360 is equal to L by 2 pi r is equal to A by pi r square from 1 and 2. Example 3. In a clock, the minute hand is of length 14 cm. Find the area covered by the minute hand in 5 minutes. Solution. Note that in 60 minutes, the minute hand rotates through 360 degree. In 5 minutes, it will rotate through an angle is equal to 5 multiplied by 360 by 360 is equal to 30 degree. Central angle theta is equal to 360 degree. Now, radius of the circle r is equal to length of the minute hand is equal to 14 cm. To find area of the sector A, area of the sector is equal to theta by 360 x pi r square. Area of the given sector A is equal to 30 by 360 multiplied by 22 by 7 multiplied by 14 square is equal to 1 by 12 multiplied by 22 by 7 multiplied by 196 is equal to 51.33. The area covered by the minute hand in 5 minutes is 51.33 cm square. Example 2. Find the length of the arc of the circle of diameter 8.4 cm with area of the sector 18.43 cm square. Also find measure of the arc. Solution. Given area of the sector A is equal to 18.48 cm square and diameter is equal to 8.4 cm. To find measure of the arc, theta is equal to length of arc L is equal to radius r is equal to 8.4 by 2 is equal to 4.2 cm. Length of the arc is L and the measure of the central angle is theta. Area of the sector A is equal to r by 2 multiplied by length of an arc. 18.48 is equal to 4.2 by 2 multiplied by L. L is equal to 18.48 multiplied by 2 by 4.2 is equal to 8.8. L is equal to 8.8. L is equal to theta by 360 degree multiplied by 2 pi r. 8.8 is equal to theta by 360 multiplied by 22 by 7 multiplied by 4.2. Theta is equal to 8.8 multiplied by 360 multiplied by 7 by 2 multiplied by 22 multiplied by 4.2. Theta is equal to 120. The length of the arc is 8.8 cm and measure of the arc is 120 degree. Area of segment of a circle. A segment of a circle is the region bounded by a chord and an arc. Steps for finding the area of segment of a circle. Find the area of the corresponding minor sector OPQR. Find a triangle POQ. Area of minor segment PQR is equal to AO minus PQR minus A triangle POQ. Area of minor segment PQR is equal to AO minus PQR minus A triangle POQ. Area of major segment PAQ is equal to area of circle minus area of minor segment. Area of segment is equal to r square pi theta by 360 minus sin theta by 2. Example 2. In figure 6.16, O is the center and segment PQ is chord of the circle. Triangle POQ is equal to 90 degree. And area of shaded region is 140 square centimeter. Find the radius of the circle. Pi is equal to 3.14. Solution. Given central angle theta is equal to 90 degree and area of shaded region is equal to area of the segment 114 square centimeter. To find radius of the circle is equal to area of the segment is equal to r square pi theta by 360 minus sin theta by 2. 114 is equal to r square 3.14 multiplied by 90 by 360 minus sin theta by 2. 114 is equal to r square 3.14 by 4 minus 1 by 2. 114 is equal to r square 1.14 by 4. R square is equal to 114 multiplied by 4 by 1.14. R square is equal to 400. R is equal to 20. Radius of the circle is 20 centimeter. Euler's formula. F plus V is equal to E plus 2 or F plus V minus E minus 2, where V stands for number of vertices, F stands for number of faces, E stands for number of edges. This relationship is referred as Euler's formula. Activity 1. Observe the given solid figures of polyhedrons and compare the table. Here, V stands for number of vertices, F stands for number of faces, E stands for number of edges. Name, figure, FVE. Cuboid, 6, 8, 12. Triangular pyramid, 4, 4, 6. Triangular prism, 5, 6, 9. Pyramid with square base, 5, 5, 8. Prism with square base, 6, 8, 12. Pyramid with hexagonal base, 7, 7, 12. Prism with hexagonal base, 8, 12, 18. Surface area and volume. The total surface area of a solid is the sum of the areas of its faces. Amount of space occupied by a solid object is called volume. Cuboid. A solid bounded by 3 pairs of parallel plane surface is called parallelopiped. The plane surfaces are known as the faces of the parallelopiped. Rectangular parallelopiped has 6 rectangular faces. 2 of them are base faces and the remaining 4 are vertical faces. 3-dimension faces share are length, breadth and height, B, L, B and H respectively. Formulae. Total surface area of the cuboid ST is equal to 2LB plus BH plus LH. Vertical surface area of the cuboid is equal to 2L plus B plus H. Diagonal of the cuboid is equal to under root L square plus B square plus H square. Volume of a cuboid is the product of the area of the base and height of the cuboid. Volume of a cuboid is equal to area of base multiplied by height is equal to L multiplied by B multiplied by H. Cube. If all the edges of the cuboid are equal in length, then it is called a cube. Thus, cube is special type of cuboid where L is equal to B is equal to H. If the length of each edge of cube is L units, the total surface area of the cube is equal to 6L square units. Volume of cube is equal to L cube cubic units. Diagonal if the cube is equal to under root 3L units. 2 cubes, each with 12 centimeter edge, are joined end to end. Find the surface area of the resulting cuboid. Solution. Given, for each cube side is equal to 12 centimeter. For the resulting cuboid, L is equal to 12 multiplied by 2. 12 multiplied by 2 centimeter is equal to 24 centimeter. B is equal to 12 centimeter and H is equal to 12 centimeter. Total surface cube area of a cuboid is equal to 2LB plus BH plus LH is equal to 24 multiplied by 12 plus 12 multiplied by 12 plus 24 multiplied by 12 is equal to 288 plus 144 plus 288 is equal to 720 is equal to 1440 square centimeter. The total surface area of the resulting cuboid is 1440 square centimeter. Right circular cylinder. If the radius of the base of cylinder is r and its height is h, then curved surface area of the cylinder SC is equal to 2 pi RH. Area of two circular faces is equal to 2 pi r square. Total surface area of the cylinder ST is equal to 2 pi r h plus r. Volume of cylinder is equal to area of base multiplied by height is equal to pi r square h. Note, all the right prisms have top and base surface congruent and parallel to each other and lateral faces perpendicular to the base. Volume of right prism is equal to area of base multiplied by height. Example 1. The radius and the height of a cylinder are 10 cm and 12 cm respectively. Find the curved surface area and the total surface area. Pi is equal to 3.14. Solution. Given radius r is equal to 10 cm, height h is equal to 12 cm. To find curved surface area SC and total surface area ST. Curved surface area of a cylinder SC is equal to 2 pi RH is equal to 2 multiplied by 3.14 multiplied by 10 multiplied by 12 is equal to 753.6. Total surface area of a cylinder ST is equal to 2 pi r plus h is equal to 2 multiplied by 3.14 multiplied by 10 plus 12 is equal to 2 multiplied by 3.14 multiplied by 10 multiplied by 22 is equal to 1381.6. The curved surface area of cylinder is 753.6 cm square and the total surface area of cylinder is 1381.6 cm square. Right circular cone. A cone with radius of base r and height h is shown in the adjoining figure. Slant height L is equal to whole root h square plus r square. Curved surface area of cone is equal to pi rl. Area of the base of a cone is equal to area of the circle is equal to pi r square. Total surface area of the cone is equal to pi r multiplied by L plus r. Volume of cone. Volume of cone is 1 by 3 times the volume of the cylinder. Volume of the cone is equal to 1 by 3 pi r square h. Frustum of the cone. Frustum is Latin word meaning piece cut off. If the cone is cut off by a plane parallel to the base not passing through the vertex, two parts are formed as cone, a part towards the vertex. Frustum, a cone, the part left over on the other side, that is, towards base of the original cone. Let h be the height and L be the slant height of the frustum of the cone and R1 and R2, the radii of the ends. R1 is greater than R2 of that frustum of the cone. Slant height L of the frustum is equal to whole root h2 plus R1 minus R2 whole square. The curved surface's area of frustum is equal to pi R1 plus R2 L. Total surface area of the frustum is equal to pi R1 plus R2 L plus pi R1 square plus pi R2 square. Volume of the frustum is equal to 1 by 3 pi R12 plus R2 square, R1 square plus R2 square plus R1 multiplied by R2 h. Sphere. Total surface area is equal to ST is equal to SC is equal to 4 pi r square. Note, sphere has only curved surface. Volume of the sphere is equal to 4 by 3 pi r cube. Hemisphere. A plane passing through the center of a sphere divides sphere into two equal parts. Each part is called hemisphere. Curved surface of area of hemisphere is equal to SC is equal to 2 pi r square. Total surface area of hemisphere is equal to area of curved surface and area of circle is equal to 2 pi r square plus pi r square. Total surface area of hemisphere is equal to 3 pi r square. Volume of the hemisphere is equal to 1 by 2 multiplied by 4 by 3 pi r cube. Volume of hemisphere is equal to 2 by 3 pi r cube. Example 4. Find the number of the coins of 2.2 cm diameter and 0.2 meter thick can be made from a right circular cylinder of height 0.2 meter and diameter 8.8 cm. Solution. Each coin is cylinder of diameter 2.2 cm. That is, radius R1 is equal to 22 by 7 is equal to 1.1 cm and height H1 is equal to 0.2 cm. Volume of coin is equal to pi r square H1 is equal to pi multiplied by 1.1 whole square multiplied by 0.2. The right circular cylinder from which coins are made has diameter 8.8 cm. That is, radius R2 is equal to 8.8 by 2 is equal to 4.4 cm and height H2 is equal to 0.2 meter. That is 20 cm. Volume of a cylinder is equal to pi R2 square H is equal to pi multiplied by 4.4 whole square multiplied by 20. Number of coins that can be made is equal to volume of right circular cylinder by volume of coin is equal to pi multiplied by 4.4 whole square multiplied by 20 by pi multiplied by 1.1 whole square multiplied by 0.2 is equal to 4.4 multiplied by 4.4 multiplied by 20 by 1.1 multiplied by 1.1 multiplied by 0.2 is equal to 4 multiplied by 4 multiplied by 100 is equal to 1600. 1600 coins can be made from the given right circular cylinder.